Alright, supercells. I really shouldn't have to say anything else. I mean, supercell. It explains it all. So, a giant storm that's very powerful. So, super in the fact that it's big, super in the fact that it's dangerous. Okay, so these storms produce extremely dangerous weather. Now, how big? Well, they can be tall. They can be 20 kilometers tall. They can be 50 kilometers across. Okay, that's big. Okay. Another thing that comes out of supercells is mesocyclones. Now, we've already talked about mesocyclones. That means like middle size, low pressure, right? Well, 50 kilometers, that's, well, 20, that could be local. You're getting on the big side of the meso. But these mesocyclones, when they're talking about that, they're talking about these supercells, these things that are just giant. Now, when you see a mesocyclone supercell, you watch out, because tornadoes, I don't want to say usually, but they form a lot in the mesocyclone. Okay, if you see a mesocyclone, if any is coming your way, you need to watch it because tornadoes are often there. Now, the other thing about these mesocyclone supercells is not only do they have tornadoes, these are the guys that make the big F3, F4, F5 tornadoes. Like, we haven't got to that rank, but the big scary ones, okay? The mesocyclone supercells, if you see one is coming, watch it carefully, okay? Because these guys tend to have the vertical winds that will cause the tornadoes. So this is a picture of a mesocyclone supercell, right? Giant area, twirling, scary. I'll just go back up to the title here. Alien invasion? No, just a massive supercell storm. Right? Like I said before, I'm not really big into photography, but this guy, wow. So here's the video for it. Let's see if I can make it full screen here. No. So I'll just watch it little screen. Love the dramatic music. But you could see why they would think alien invasion. You can see the clouds being caught up in it. You can see the twirling. You can see the lightning. See the dust being brought up. Now, if you look down here, it says, okay, it's in Phoenix. Thank you. In Phoenix, and blah, blah, blah. And you see squalls. And we'll talk about squall lines coming up. Okay, so this is what they look like, right? This is what it looks like from the satellite image. Like a hidden Mickey. 1, 2, 3. Anyway, then you can see the tornado that it's causing, right? And then you can see kind of a scientific breakdown. The upper level winds, right? The anvil head, overshooting top, the mid-level winds, and then these guys get twirled around. You get another, now this is usually a CT air, you get that being pulled in and twirled around, and there's your tornado. Okay, you have your gust front, you have your downdrafts, I'm sure you've got your updrafts, especially up here. Big storm, lots going on, right? squall lines. Like I said, he looked for a squall. So squall lines, what are they? Basically bands of thunderstorms. And I'll show you a picture in a minute, but a band of a thunderstorm. And so what happens here is just like I showed you in the other picture, the CT air is pulled in. Now what's the CT air? The warm, the continental tropic air. Warm, dry. Right? Dry is actually denser than moist. So this is the one that's going to sink, hence it kind of gets twirled at the bottom, and it pushes that moist air up. Let me go back to that picture. So your CT air comes in, it's going to sink, and your moisture is getting pushed up, which is going to cause the rain. Now, sometimes you see mammatus clouds. We talked about mammatus clouds, right? And they'll come just before the squall line. So if you ever see a mammatus cloud, get inside quickly. All right, and the dry line is where they form, where there's an abrupt change in moisture. Okay, so here's the mammatus clouds, right? Just to jog your memory there. Here's the CT, here's the dry line. So you have your moist, your cold, your hot and dry. Everything's mixing like you saw in that one picture. And you're getting lots of tornadoes, lots of thunderstorms right along here. Okay, so here's two videos, and I have them pulled up, so give me a sec. So this video shows you kind of what a squall line is.
A squall line is, simply put, lines. Squall lines can also be called multi-cell linear storms, but the most common term used to identify these storms is squall line. A squall line consists of storms situated along a gust front at the leading edge of the line. The gust front acts as the system's updraft, as air is lifted upwards along the leading edge of the line, even as colder air rushes out and away from the storm's course. Lines of storms can persist for hours and even days as they move east or south. A line of storms will see its biggest severe weather threats along and just behind the gust front. The main severe weather threat from squall lines is damaging winds, but large hail and even weak tornadoes are possible. Another threat is significant flash flooding, especially in situations where the line itself is moving slowly as individual cells move over the same areas repeatedly. Linear systems are easy to track and predict, as they typically follow a pretty straight path. Lines of storms can be incredibly damaging, and thus you should always pay special attention when one is approaching your area.
Okay, so the last video talked about gust fronts and how it can be really breezy. Well, I just wanted to show, I found this as I was looking through videos, and I just thought this was hilarious, so I had to show it to you. I had to show it to somebody. And since you can't argue with me, I'm showing it to you.
I know why Reed Timmer turns his hat backwards. Because it will blow
Okay,
your
so
hat
he's
off.
turning his hat back. He turned it backwards because it will blow his hat off. He's sitting in front of a squall line. Now, apparently, he doesn't like his hat backwards because he just naturally turned it around. Probably not even thinking about it. And he did say it's getting cold because your storm's coming, your temperature's going to drop. The front is going to be a cold gust front.
Temperature just
It's
dropped.
also very gusty.
Wow. There went my hat.
And there goes his hat. Like, he turned it around so it wouldn't do that, and then he just forgot and turned it back, and
Crap.
there goes his hat. He goes chasing after it. Alright, so this is like a 20-minute thing. It's not as scientific, so technically I probably shouldn't show it. Anyway, that was... okay, back to the science. So, another thing that supercells can do, not only are they going to do a mesocyclone, but they could also do a mesoscale convective complex, otherwise known as an MCC. Well, look at this. 1, 2, 3, 4. See these guys? 3, arguably 4 mesocyclones within this mesoscale convective complex. All right, so if you couldn't tell, these are large oval to circular clusters. Huh, really? Okay. A total of the area these things can cover over 100,000 square kilometers. Not only are these things huge, but they go really slowly, and they can last for hours, like half a day. Just there, a strong, strong storm.